Okay, so in today's lecture, we'll see working of a reciprocating compressor, reciprocating air compressor. Can anyone tell me what is the function of a compressor?
It
Yes,
increases the intensity of pressure or pressure of gas.
excellent, excellent. The function of compressor is to increase the pressure intensity of air or gas. If it is increasing pressure intensity of air, it is called as air compressor, right? If it is increasing pressure intensity of a gas, it is called as general compressor. Gas compressors in general, they are called as compressors. Okay, anyway, I believe that this is clear to you. Do you know one thing? Gases are compressible, whereas liquids, they are incompressible, right? Gases are compressible. So how gases are compressed? How we increase pressure intensity of gases?
by decreasing of value.
Excellent. Simply by reducing the volume. So see, simply in air compressor, we just do three things. Which things we do? Simply air is taken inside the cylinder, right? Air is compressed, that is its volume is reduced, and that high pressure air is given to the reservoir. I believe that this concept is clear to you, right? We'll see the construction and working so that the concept will be more clear to you. But tell me what the air compressor does. It takes in the atmospheric air. Atmospheric air is taken inside, right? See here, air compressor takes in atmospheric air, compresses it. Compresses it means reduces its volume, right? Increases its pressure. And this high pressure air is delivered to a storage vessel, which is also called as reservoir. Now see, in compression, work is done on the gas, right? Compressor is done by a prime mover. Compressor is an energy absorbing device. Tell me whether compressor is an energy absorbing device or energy producing device.
Energy absorbed.
Yes,
Energy
it is an
absorption.
energy absorbing device. Very good. Now see, what is the difference between pumps and compressors? Yes, it is very simple. Pumps are used to compress.
Gas. Liquid.
Pumps
Any gas.
Liquid.
Only liquid.
liquids. Pumps are used to increase pressure intensity of liquids, and compressor is used to increase pressure intensity of gas. Okay. Now, tell me, what are the applications? Where have you seen compressors? As we have discussed that in refrigerator also, compressor is there, right? रेफ्रिजरेटर मध्ये पण खालच्या साईडला एक कॉम्प्रेसर असतो. बॉटम साईडला बॅक एंडला एक कॉम्प्रेसर असतो, त्याला म्हणतात हार्मिटिकली सील्ड कॉम्प्रेसर. ओके, सो इन एअर कंडिशनर, रेफ्रिजरेटर वी यूज कॉम्प्रेसर. इन न्यूमॅटिक डिव्हाइस, हॅव यू हर्ड दिस वर्ड हायड्रॉलिक न्यूमॅटिक? हॅव यू हर्ड दिस वर्ड न्यूमॅटिक?
No, sir.
ओके, have you seen somewhere written like air brakes? काही गाड्यांवर तुम्ही लिहिलेलं बघितलं असेल, एअर ब्रेक असं लिहिलेलं असतं. वाचलंय कधी ते एअर ब्रेक?
Yes, sir.
Yes, sir.
See, air brake means pneumatically operated brake. The brakes which are operated using compressed air, they are called as air brakes. Okay, anyway, so there in pneumatic device, see there are devices like, there are some devices, for example in mining, आपण जेव्हा मायनिंग मध्ये काम करतोय तेव्हा आपण इलेक्ट्रिसिटी वापरू शकतो का? Can I take a electric wire inside a mine?
No, sir.
No, because why we cannot take electric wire inside a mine? Because in case of, if there is any, what we can say, short circuit, or if there is any small amount of sparking, your mine will get exploded, right? So due to safety concerns, we don't use electric things over there, right? So we take compressed air. and we use pneumatic devices over there. We use pneumatic devices over there. Pneumatic devices means the devices which are operated using compressed air. Yes, what are the pneumatic devices? Or how pneumatic devices are operated? Yes, pneumatic devices are operated using compressed air. Pneumatic devices कसे operate करतो आपण?
With the help of compressed air.
Yes. आणि hydraulics and pneumatics नावाचं एक सायन्स आहे. There is a science called as hydraulics and pneumatics. Whenever we are using compressed oil, that is called as hydraulics. Right? And whenever we are using compressed air, that is called as pneumatics. I believe that this concept is clear to all of you. Is it clear to all of you?
Yes, sir.
Yes, sir.
See, I just wanted to tell you only one simple thing. Pneumatic devices means the devices which operate on compressed air. So in pneumatic devices, we need air compressor. I believe that this concept is clear to you. Just 1 minute. Okay. Then in refrigeration, it may be household refrigeration or industrial refrigeration. We use compressor. Then we use hydraulic compressors for industrial machines. Just now we discussed hydraulics and pneumatics. So we need hydraulic compressor as well as pneumatic compressor. Then air compressors are also needed for industrial manufacturing. Like in spray printing, we use compressed air. Okay. So as far as our syllabus is concerned, we are having this compressor, which is called as a reciprocating compressor. See, this compressor is called as a reciprocating compressor, and this compressor is called as a rotary compressor. It is very simple. This is called as reciprocating because in this case, air is compressed by reciprocating action of piston. See this, all of you, can you see this?
Yes, sir.
See, this is called as piston. What is the name of this thing?
Piston.
Piston. This is called as cylinder. The outer one is called as cylinder. So there is piston inside the cylinder, right? So when your piston will move from this bottom position to this top position, what will happen to volume of air? Volume of air will get reduced, right? And when volume of air gets reduced, its pressure increases. So I believe that this concept is clear to you. I will show you its working in detail. Just I wanted to tell you that there are two types of compressors. One is reciprocating and one is rotary. Right? Now see, this is rotary because it works on, here there is rotary motion of this vanes, right? Okay. Now see, we'll see reciprocating compressor. Now see, this is piston. Okay. I will show you one more so that the concept will be clear to you. See, this is called as piston. This is called as cylinder. What is the name of this?
Cylinder.
Cylinder. This wall, this is called as inlet wall. This is called as
Inlet wall.
Inlet.
inlet wall.
Inlet.
This is outlet wall. This is outlet wall. This is suction line and this is delivery line. Right? Or this is input and this is output. Or this is air at the inlet and this is air at the outlet. Now see, piston reciprocates inside the cylinder. This rod is called as connecting rod. Ha jo rod ahe, this is called as connecting rod. See, this is called as piston. What is the name of this?
Piston.
Piston.
This is called as cylinder. This is called as cylinder. This is intake wall or suction wall. This is discharge wall or outlet wall. Intake wall, outlet wall, or inlet wall, outlet wall, or suction wall, discharge wall. All names are there, right? So just we'll say this, that this is suction lining, so this is suction wall, and this is discharge line, so this is discharge wall. Or we can say like inlet wall and outlet wall. Now see, this is called as piston. This is called as connecting rod. What is the name of this? The rod which is connected from this point to this point. This is called as connecting rod. Okay. Name of this thing is called as crank. What is the name of this?
Crank.
Crank. And see, this circle indicates crankshaft. See, in next lecture, we are having a cut section model over here. So I will show you the cut section model so that the concept will be more clear to you, right? Okay. Now see, piston reciprocates inside the cylinder. Piston reciprocates inside the cylinder. Crank rotates on the crankshaft, and this connecting rod converts rotary motion of crank into reciprocating motion of piston. Let's say if your motor is connected to crankshaft, what will happen? तुमची मोटर जर क्रँकशाफ्टला कनेक्टेड केलेली असेल तर काय होणार आहे? क्रँकशाफ्ट विल रोटेट. नाउ सी, व्हेन युअर क्रँकशाफ्ट विल रोटेट, युअर क्रँक विल रोटेट because your crank is mounted on the crankshaft. So initially, see, when your crank moves from this vertical position to this downward position, what will happen? Let's say now crank is at this position and it has started moving in the clockwise fashion. So tell me, when the crank moves in the clockwise manner, what will happen to piston?
Piston goes down.
Excellent. Piston goes down. मोशन क्लिअर करून घ्या. मोशन कशात बघा, क्रँकची मोशन कशी आणि पिस्टनची मोशन कशी आहे? इन टर्म्स ऑफ रोटरी मोशन अँड रेसिप्रोकेटिंग मोशन. येस, कुणाची मोशन रोटरी आहे रे आणि कुणाची मोशन रेसिप्रोकेटिंग आहे?
Piston is reciprocating.
Reciprocating.
Excellent. Piston is reciprocating. And what about crank?
It
Rotary.
is rotary.
Rotary. Very good. See, crank performs rotary motion, piston performs reciprocating motion. Reciprocating म्हणजे शेवटी ती लिनियरच आहे. Okay, so piston performs reciprocating motion, right? And what is the function of this crank connecting rod? This connecting rod converts rotary motion of crank into reciprocating motion of piston. What is the function of this connecting rod?
Connecting rod convert rotary motion of crank into reciprocating motion.
Excellent, excellent. See, in IC engine also we use same mechanism. Only there power is given from piston to crank. कॉम्प्रेसर मध्ये आपण पॉवर कशी देतो? क्रँक टू पिस्टन. आणि आयसी इंजिन मध्ये एक्झॅक्टली उलट, कारण ते पॉवर प्रोड्युसिंग डिव्हाइस आहे. या इंजिनच्या आतमध्ये पॉवर तयार होते. सो पॉवर इज गिवन फ्रॉम पिस्टन टू क्रँक. इन कॉम्प्रेसर पॉवर इज गिवन फ्रॉम क्रँक टू पिस्टन. So in compressor, we give power to crankshaft. So crank is mounted on the crankshaft. So crank will rotate on the crankshaft. And when crank will rotate on the crankshaft, piston will reciprocate inside the cylinder. Now see, when crank moves from this position in the clockwise direction to this position, piston will move from its top dead center position to bottom dead center position. See, when crank will move from this position to this position, tell me how piston will move?
Downward.
Yes, excellent. It will move in the downward direction. You can see A and C. See, A, crank is at this position, so piston is at topmost position. C, crank is at this position, so piston is at bottommost position. आता पिस्टनची ही जी पोझिशन आहे, this position of piston is called as TDC. Right? It is an abbreviation. TDC means top dead center position. What is TDC?
Top dead center position.
Top dead center. Right? And see, this position of piston, this is called as BDC. The long form is bottom dead center position. BDC means bottom dead center. BDC. See, it is very simple. Topmost position achieved by the piston is called as TDC, and bottommost position is achieved by the piston is called as BDC. Yes, can anyone repeat? What is TDC?
Top dead center position.
Excellent. And what is BDC?
Bottom dead center
Bottom dead
position.
center position.
Excellent. Now look at the figures carefully and tell me in which figure you can see TDC and in which figure you can see BDC.
A मध्ये TDC.
First figure
हा, फर्स्ट फिगर मध्ये ए मध्ये कोणती आहे रे पोझिशन?
TDC.
TDC.
TDC. And
In third position BDC.
येस, इन सी अँड डी, हे बघा सी आणि डी मध्ये पण तीच दाखवले त्यांनी, फक्त त्यांनी हे दाखवले की इथं हे संपतं आणि इथून मग तो पुढे चालू करतो. सी इन ए इट इज ॲट TDC and in C and D it is at BDC. See, initially crank will move from this position to 90 degrees to 180 degrees. When crank is at 180 degrees, piston is at BDC. Now crank will move from 180 to 360. So when crank will move from 180 to 360, tell me what will be the position of piston? How will it move? When crank
Upward.
moves from 180 to
Bottom to upward.
360. Yes, please repeat.
BDC.
Bottom to upward.
येस, BDC टू क्रँक 180 ला. हे बघा ही पोझिशन आहे 0. इथे समजा हॉरिझॉन्टल झाला क्रँक, त्याला आपण म्हणतो 90. इथे बॉटम मोस्ट जे आहे त्याला आपण म्हणतो 180. इथे या साईडला असेल त्याला आपण म्हणतो 270. आणि टॉप मोस्ट पोझिशनला जर असेल हा परत 0 आणि 360 सेमच आहेत पोझिशन. टेल मी व्हेरी ऑनेस्टली, इज इट क्लिअर टू यू? सो वेन क्रँक मूव्स फ्रॉम 0 to 180 degree, piston moves from
TDC to BDC.
excellent.
BDC to TDC.
See, it will move from TDC to BDC. क्रँक जेव्हा 0 अंशापासून 180 अंशापर्यंत जातो, when crank moves from 0 degree to 180 degree, क्रँक इथे तुमचा आणि क्रँक 180 ला जातोय. when crank moves from 0 to 180, see this is your position of crank. When it moves from 0 to 180, your piston will move in the downward direction. It will move from TDC to BDC, right? And when crank moves from 180 to 360, what will happen to piston?
BDC to TDC.
Yes, it will move from BDC to TDC. Tell me very honestly, is it clear to you? Now see.
Yes, sir.
Yes. So there are two strokes. See, initially the crank moves from 0 to 180. So the piston moves from TDC to BDC. The inlet valve or suction valve is opened and air is admitted inside the cylinder. Tell me honestly, is the suction stroke clear to you? What happens in suction stroke? सक्शन म्हणजे एअर आतमध्ये घेणं, कॉम्प्रेशन म्हणजे एअर कॉम्प्रेस करणं आणि डिस्चार्ज म्हणजे एअर डिलिव्हर करणं. There are three things in a compressor, right? What three things? Suction, compression, and discharge. Tell me, what are the three operations in a compressor?
Suction, compression, and discharge.
Excellent. Suction, compression, and discharge. Let us understand one by one. Before that, tell me, is this construction of compressor clear to you? This is a reciprocating compressor. I will just put this pointer and you just tell me name of that component. Which is this component?
Piston.
Very good. Which is this component? Shaded line?
Piston.
Yes,
Cylinder.
piston was correct. Now this component?
Cylinder.
Cylinder. Very good. Which is this component?
Connecting rod.
Connecting rod.
Which is this component?
Crank.
Crank.
Excellent. And which is this component?
Crankshaft.
Excellent. Very good. Very good. This is called as crankshaft. So tell me where crank is mounted? Crank is mounted on. What will be your answer? Crank कशावरती माउंट करतो आपण?
Connecting rod.
नाही. हा जो
Motor.
क्रँक आहे हा कशावर माउंट केलाय रे?
Crankshaft.
Yes, it is mounted on the crankshaft.
Crankshaft.
हा तुमचा crankshaft आहे. Crank is mounted on the crankshaft. Now tell me, crank performs which type of motion?
Rotary.
Rotary.
Motion.
It is rotary motion. Piston performs which type of motion?
Reciprocating.
Reciprocating motion.
Very good. Very good. It performs reciprocating motion. Okay. What is the name of this?
Suction.
Valve.
Inlet.
Right? Which valve is there?
Inlet.
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 It is called as inlet valve
Inlet.
or intake valve or suction valve. Right? There are 2-3 names given to the same thing. Right? Okay. What is the name of this?
Discharge valve.
Outlet valve.
Discharge valve.
Outlet valve.
Inlet valve or discharge valve. Right? Okay. Now see, initially both walls are closed, right? The piston moves from TDC to BDC. Now, when piston starts moving from TDC to BDC, the pressure inside the cylinder falls, right? Because there is creation of vacuum, and due to which the suction wall or inlet wall opens and air is sucked inside the cylinder. So this stroke is called as suction stroke. This stroke is called as suction stroke. So what happens in suction stroke? The piston moves from TDC to BDC, inlet wall opens and air is admitted inside the cylinder. See, stroke means the motion of piston from TDC to BDC. That is called as a stroke. Right? Anyway, we will say that suction operation or only suction. So what happens in suction? What is the motion of piston in suction?
TDC to
move from
BDC.
TDC to BDC.
Yes, the piston moves from TDC to BDC, inlet wall is opened and air is admitted inside the cylinder. I believe that this concept is clear to you. Suction stroke मध्ये काय होतं हे सगळ्यांना क्लिअर आहे?
Yes,
सक्शन
sir.
स्ट्रोक मध्ये पिस्टन TDC पासून BDC कडे जातो, इनलेट वॉल ओपन होतो आणि एअर आतमध्ये ऍडमिट होते and air gets admitted inside the piston cylinder arrangement. Right? Now, when air is totally sucked, both walls are closed, inlet wall as well as delivery wall or discharge wall, they are closed. And now the piston will move from BDC to TDC. Piston will move from now BDC to TDC and both walls are closed. Now see, this is a fixed boundary, this is a moving boundary, right? Both walls are closed. So this end is closed and this end is moving in the upward direction. So what will happen to the volume of air? Yes, inlet wall as well as delivery wall are closed and piston is moving from BDC to TDC. So what will happen to volume of air?
Decreases.
Decreases. And as the volume decreases, pressure increases, right? So this is called as compression stroke. In compression stroke, piston moves from BDC to TDC. Piston moves from BDC to TDC. Volume of air is decreased and its pressure is increased. Tell me very honestly, is this concept clear to all of you?
Yes, sir.
So tell me what happens in compression stroke?
Piston moves from BDC to TDC.
Excellent. And what happens? Why it is called as compression?
Because air decreases its pressure and air.
Volume.
Yes. Volume of air decreases. See, it is very simple. See, in compression stroke, volume of air decreases. Right? We say like PV upon T is equal to constant. So if volume is reducing, P should increase. Right? Okay. So pressure increases. Right? So in compression stroke, the piston moves from BDC to TDC. Right? Volume of air decreases and its pressure increases. Now see, at the end of compression stroke, when piston is at TDC, this discharge wall is opened, right? This discharge wall is opened and this compressed air, right? This compressed air, that is high pressure air, is taken to this discharge wall or discharge pipe. Tell me very honestly, are these three things clear to you? First one is suction, second is compression, and third is delivery. So what we do in case of a compressor, we take air inside the cylinder, we compress it, we increase its pressure, and then we store it in a reservoir. Okay, so there are three things. One is suction, second is compression, and third is delivery. What would we do in case of suction? Yes, what we do in
Intake of
suction?
air. Intake
Yes.
of air.
Air is sucked inside the cylinder. Air is admitted inside the cylinder. So in suction stroke, the piston moves from TDC to BDC, inlet wall opens and air is admitted inside the cylinder. Right? Now see, in suction stroke, your piston moves from TDC to BDC. Then after suction stroke, inlet wall is closed. So in compression stroke, inlet wall as well as outlet wall are closed and piston is moving from BDC to TDC. So volume of air decreases, and as volume of air decreases, its pressure increases. So this is compression stroke, compressing the air, reducing its volume, increasing its pressure intensity. This is called as compression. And after compression stroke, when piston is at TDC, discharge valve is opened and this high pressure air is taken out of the cylinder and it is stored in a reservoir. Okay, chalo, who will explain me this entire working? Yes, I will help you. You please start. I will help you. Yes, am I audible?
Yes, sir.
Okay, okay. Tell me, what are the three things? Okay, initially we'll discuss about components. Tell me, what are the components in a reciprocating compressor? Just tell me the names.
Piston,
Yes, yes,
Piston,
piston is there.
cylinder,
Yes,
connecting rod,
yes, connecting rod is there. Then
Crank.
crank is there. Good.
crank,
Crankshaft is there. Good.
crankshaft,
Then which two walls
inlet,
are there?
Inlet wall, outlet
inlet
inlet
wall.
wall,
wall
and
and
outlet
outlet
wall.
wall.
Inlet wall and outlet wall, or suction wall and delivery wall. Okay. Tell me what happens in a suction stroke. In a suction stroke, crank moves from which position to which position?
TDC to BDC,
TDC to BDC.
Crank. I'm asking about crank.
clockwise,
BDC to TDC.
No, no.
0 to 180.
clockwise,
Excellent. 0 to 180. In the suction stroke, crank moves from 0 to 180. See, this is your crank. It will move from 0 to 180. Right? And your piston will move from TDC to BDC. When crank is at 0, piston will be at the topmost position. When crank will start moving from 0 to 90, piston will start moving in downward direction. Again from 90 to 180, again it will move in the downward direction. When crank is at 0, piston is at TDC. When crank is at 180, piston is at BDC. When crank moves from 0 to 180, piston moves from TDC to BDC. So what happens in suction stroke? I'm sure you can tell. किती सोपं आहे बघा, मी तुम्हाला सोप्या वाक्यामध्ये सांगतो, तुम्ही रिपीट करा. इन सक्शन स्ट्रोक piston moves from TDC to BDC, inlet wall is opened and air is admitted inside the cylinder, right? Then in compression stroke, piston moves from BDC to TDC. See, it is very simple, suction, right? Piston moves from TDC to BDC, inlet wall is opened and air is admitted inside the cylinder. Compression, piston moves from BDC to TDC, air is compressed, its volume is reduced, its pressure is increased. And then delivery means this outlet wall is opened and air is taken, that compressed air is taken out of the cylinder and it is stored in the reservoir or in the receiver. Tell me, is this concept clear to you?
Yes, sir.
Okay, I believe that the concept is clear to you. See, here you can see it in a more clear manner. See, this is piston, this is cylinder, this is inlet wall, this is delivery wall or discharge wall, this is inlet line. See, when piston moves from TDC to BDC, this air is sucked inside the cylinder. Then piston moves from BDC to TDC, it is compressed, and at the end of compression stroke, this wall is opened and this high pressure air is taken from the cylinder. Now see, this is principle of operation, right? This piston is driven from the crankshaft, right? There is a crank which rotates on the crankshaft. This is connecting rod. This one is connecting rod. This is totally called as cylinder. This is called as piston. Okay, intake valve. This is inlet valve. This is delivery valve. Okay. We'll see an animation so that the concept will be clear to you.
A reciprocating compressor compresses refrigerant vapor in a cylinder using a piston.
Now see, this is the, what is the name of this?
Piston.
Piston.
In a way, reciprocating
Piston.
compressors are like automobile engines.
See, this is, can anyone tell me which is this?
Connecting rod.
Very good,
Connecting
connecting rod.
rod.
This is
Crank.
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 Excellent, very good.
Pistons are directly driven through a wrist pin and connecting rod from a crankshaft. Depending on their size, reciprocating
See, this is crankshaft. इथपर्यंत जो पार्ट आहे हा क्रँकशाफ्ट आहे आणि क्रँकशाफ्टला हा जो कनेक्टेड पार्ट आहे दिस इज कॉल्ड एज क्रँक. टेल मी व्हेरी ऑनेस्टली, इज इट क्लिअर टू यू?
Yes, sir.
Yes, sir.
compressors may have one or more cylinders. Multiple cylinders may be arranged in line, opposed, or in a V. In each
See, generally we use single cylinder, but nowadays people are using multi-cylinder as well. Okay, and see, they can be kept in different positions, right?
multiple cylinders
They
may
can
be
be in line, right? They can be placed in opposite fashion, right? Like two cylinders, they are facing, moving like this, two cylinders, they are moving like this, or they can be placed in a V manner. In aeroplanes, we use V engines, right? See, that concept is different. That is IC engine, okay? See, in aeroplanes, we use this kind of structure.
or in a V. In each cylinder, reciprocating compressors have both a suction valve and a discharge valve. These valves give the compressor its ability to pump refrigerant vapor against a pressure difference. They're usually located in the head of the cylinder, in passages connected to the high or low pressure side of the system. Let's follow the compression process in a single cylinder reciprocating compressor during one complete revolution of the crankshaft.
See, this is suction line, this is discharge line, this is suction wall, here you can see, and this is discharge wall. This is piston, this is cylinder, this is connecting rod, this is crank.
Starting with the piston at the top of its stroke, or at top dead center, the piston begins to move downward as the crankshaft rotates.
Now see, piston is moving from TDC to BDC.
Both valves are closed, the downward moving piston reduces the pressure in the cylinder. As the pressure in the cylinder falls below the low side pressure in the suction line, the pressure difference opens the suction valve, letting
Now see, there are two types of suction valves. One is spring operated valves which are operated directly, and one is pressure difference operated valves, right? See what happens when piston moves from TDC to BDC, the pressure inside the cylinder falls below atmospheric pressure. So this pressure is less and this pressure is more. So definitely this valve will open and air will be admitted inside the cylinder.
refrigerant vapor flow into the cylinder. The piston continues down and pulls in more vapor until the cylinder is filled.
Now see, piston is at BDC. Now it will start moving from BDC to TDC, right? And this wall is closed as well as this wall is closed.
With low pressure vapor at the bottom of its stroke. Once past bottom dead center, the piston begins its upward stroke. The suction valve closes. As the piston moves up, it reduces the volume of the space in the cylinder, increasing the pressure of the vapor. When the pressure in the cylinder exceeds the high side pressure in the discharge line, the pressure difference pushes the discharge valve open, letting the compressed vapor flow out of the cylinder. This continues until the piston reaches the top of its stroke and most of the compressed vapor has been expelled into the discharge line. When the piston begins its downward stroke, the discharge valve closes. The complete cycle then repeats during each revolution of the crankshaft. This is the mechanical positive displacement vapor compression cycle using a reciprocating compressor. Please take a moment to
Tell me honestly, any difficulty with this?
No, sir.
Yes, sir.
So I think that after seeing this animation, the concept is very crystal clear to you.
Yes, sir.
Okay,
Yes, sir.
okay, fine. So we have seen reciprocating compressor, right? Okay. See, working of reciprocating pump is similar to a reciprocating compressor. Anyway, now we'll see from exam point of view. Now see, what is air compressor? Air compressor is a mechanical device that increases pressure of the gas, right? Generally, we are not talking about air compressor, we are talking about any kind of compressor. So compressor is a device that increases pressure intensity of a gas by reducing its volume, right? Okay, air compressor is a specific type of gas compressor, right? In which we compress the air. Now see, compressors are similar to pump, right? Because pumps increase pressure intensity of liquids and compressor increases pressure intensity of gases. Now see, these are the applications of air compressor for inflating tires of automobiles, राईट. टायरमध्ये हवा भरण्यासाठी आपण जी एअर यूज करतो ती कॉम्प्रेस्ड एअर असते, त्या ठिकाणी कॉम्प्रेसर असतो. ओके, देन क्लिनिंग ऑफ मशीन पार्ट्स. इफ यू सी इन इंडस्ट्री, राईट, फॉर क्लिनिंग दे यूज कॉम्प्रेस्ड एअर. तुम्ही कधी गाडी वॉशिंगला जर नेली फोर व्हीलर, तर आतला जो पार्ट ते क्लीन करतात गाडीच्या आतमधलं, ते कॉम्प्रेस्ड एअरने ते क्लीन करतात. ओके, देन फॉर स्प्रे पेंटिंग ऑफ व्हेकल्स we use compressed air. So there are plenty of applications of the compressed air. So tell me, is the concept of compressed air clear to all of you?
Yes, sir.
Okay. Now we'll cover one more bit, that is turbine. Okay, already we have seen this. We have seen wind turbine, we have seen impulse turbine, right? Now tell me, what we do in case of a turbine? Yes. Can I say that in a turbine, the energy possessed by fluid is converted into mechanical energy?
Yes, sir.
Yes, sir.
Okay, so what we do in a turbine, we utilize the energy possessed by the fluid and we convert that energy into mechanical energy. So this is a nozzle. We have seen this in case of hydroelectric power plant. This is nothing but Pelton wheel. Okay, this is nothing but a hydraulic turbine. These are the buckets, right? And this is nothing but your shaft, right? So in nozzle, the water jet comes out with a very high velocity, and when this strikes on the buckets, these buckets will experience a force and they will start rotating. So there is generation of shaft energy. And see, if this shaft is connected to an alternator, right, that will convert that mechanical energy into electrical energy. So already we have discussed this concept in detail. If you are having any difficulty, you please ask. So the concept of turbine is clear to you. Can anyone tell me what are the three types of turbines? Yes. Tell me, which turbine do we use in hydroelectric power plant? Yes, am I audible? मला सांगा, आपण हायड्रोइलेक्ट्रिक पॉवर प्लांट मध्ये कोणतं टर्बाइन यूज करतो? हायड्रॉलिक टर्बाइन, राइट. थर्मल पॉवर प्लांट मध्ये आपण कोणतं टर्बाइन यूज करतो रे? Which turbine do we use in thermal power plant or nuclear power plant?
Steam turbine.
Use steam turbine,
Steam turbine.
राइट. आणि तुमच्या सिलेबस मध्ये एक नाहीये, पण आपण गॅस टर्बाइन पण यूज करतो. गॅस पॉवर प्लांट जे असतात त्या ठिकाणी आपण गॅस टर्बाइन यूज करतो. Okay, anyway, so just remember that there are three types of turbines. Which are those? Steam turbine, hydraulic turbine, and gas turbine. If your turbine is driven by steam, it is called as steam turbine. If your turbine is driven by gas, it is called as gas turbine. And if your turbine,
Sir.
yes.
मग त्या तिघांमध्ये काय डिफरन्स असतो का स्ट्रक्चर मध्ये त्यांच्या?
खूप खूप मोठा फरक आहे, खूप मोठा फरक आहे, कारण कन्सेप्टच वेगवेगळे आहेत. आता स्टीम टर्बाईन जर आपण म्हणलं तर कशाचं कन्व्हर्जन कशामध्ये करता येते? एन्थाल्पीचं कन्व्हर्जन मेकॅनिकल एनर्जी मध्ये करते. स्टीम एनर्जी पूर्णपणे वेगळी आहे. स्टीम मध्ये हीट एनर्जी आहे, या पाण्यामध्ये कायनेटिक एनर्जी आहे. लक्षात येते मी काय म्हणतोय ते?
येस सर.
स्टीम टर्बाईन कशाचं कन्व्हर्जन कशामध्ये करताय? स्टीम टर्बाईन कन्वर्ट्स हीट एनर्जी इनटू मेकॅनिकल एनर्जी. मग त्या ब्लेड ज्या डिझाईन केल्यात आपण, त्याचा एरोडायनामिक शेप असेल, राईट. स्टीम टर्बाईनचं स्ट्रक्चर हे पूर्णपणे वेगळं असतं, हायड्रॉलिक टर्बाईनचं स्ट्रक्चर हे पूर्णपणे वेगळं असतं. द कन्सेप्ट इज टोटली डिफरंट. गॅस टर्बाईनचं स्ट्रक्चर हे जवळजवळ स्टीम टर्बाईन सारखं असतं. इट इज ऑलमोस्ट सिमिलर टू स्टीम टर्बाईन, because gases at the end of day same thing is there, right? Compressed air is there, and inside that compressed air fuel is injected, so there is combustion, and those combustion gases are passed through a gas turbine. Okay, anyway, so just remember that there is a lot of difference between the structures of these three turbines. म्हणजे हायड्रॉलिक टर्बाईन आपण एखाद्या ठिकाणी स्टीम टर्बाईन लागते त्या ठिकाणी आपण हायड्रॉलिक टर्बाईन नाही यूज करू शकत. I believe that to some extent these three things are clear to you. सी इट इज व्हेरी सिम्पल. जिथं तुमच्याकडे पाणी आहे आणि पाण्यामध्ये एनर्जी आहे तिथे तुम्ही हायड्रॉलिक टर्बाईन वापरणार आहे. तसं तर ते नावावरून पण आपण लक्षात ठेवू शकतो. स्टीम टर्बाईन मध्ये त्याला इनपुटला काय लागणार आहे? इफ द नेम इटसेल्फ इज स्टीम टर्बाईन, इट विल नीड स्टीम, राईट? इफ द नेम इज हायड्रॉलिक टर्बाईन, हायड्रॉलिक मीन्स वॉटर, हायड्रा मीन्स वॉटर, सो इट नीड्स वॉटर. And if the name is gas turbine, it needs gas. I believe that to some extent the concept is clear to you. Okay. Now tell me what we do in this hydraulic turbine. Yes. See, this water is coming out. This water jet is coming out with a very high velocity. When it will strike on the bucket, this bucket will experience a force and it will rotate. Okay. If you want, we'll see the animation, but already I think we have seen this animation, no? So we have seen this, that this is the nozzle, right? We have seen sphere. These are called as buckets. See, these are the buckets, right? These are mounted on this shaft. Now see, in our lab also, in our laboratory, we are having a fluid machinery laboratory, and in that fluid machinery laboratory we are having this turbine, right? This name of this turbine is Pelton turbine. Okay, see, these are the buckets. See, from here water jet is impinged, and due to that impact of the jet, right, this turbine rotates. So we convert kinetic energy of water into mechanical energy. Yes, if you want, we'll see this animation.
Pelton turbines are suitable for power extraction when water energy is available at high head and low flow rate. Working of Pelton turbine is simple. High-speed water jet is ejected through a nozzle. When this jet hits buckets of Pelton wheel, it induces an impulsive force. This force makes the turbine rotate. In short, Pelton.
See, when the jet, water jet strikes on the bucket, right, there is impulse force. There is impulse force. That's why this is called as impulse type of turbine. Anyway, in your syllabus, only concept of turbine is there. That turbine converts energy possessed by water into mechanical energy.
A turbine transforms kinetic energy of water jet to rotational energy. The rotating shaft runs a generator and produces electricity. But the
Now see, when water jet will strike on this bucket, right? This will rotate, and this assembly is mounted on this shaft. So your shaft will rotate, and this shaft is connected to the generator. So what that generator will do? Yes.
Mechanical converter into electrical energy.
Yes, mechanical to electrical.
And of power may fluctuate over time. A governing mechanism, which controls position of spearhead, meets this requirement. With lowering power demand, spearheaded water inlet nozzle is moved in, so that water flow rate is reduced. If power demand increases, spearhead is moved out. This will increase flow rate.
So using spearhead, see this is called as spearhead, we can control the discharge. And by controlling this discharge, we can control power output of the turbine.
This in turn makes sure that turbine will rotate at a constant specified RPM, which conforms to the power supply frequency. So this mechanism acts as a speed governing mechanism of Pelton wheel. A cut is provided.
See, this mechanism is called as speed governing mechanism. We govern the speed. We make the turbine to rotate at a constant speed. समजा तुम्हाला एक्झॅक्ट 2400 स्पीड पाहिजे, तुम्ही ऑटोमॅटिकली तो 2400 मेंटेन करू शकता. समजा 2300 आहे, तर तुम्ही काय करणार? इफ द स्पीड इज गेटिंग रिड्यूस, देन यू विल इन्क्रीज द डिस्चार्ज, राईट? किंवा स्पीड तुम्हाला जास्त मिळतोय, व्हॉट यू विल डू? यू विल डिक्रीज द डिस्चार्ज अँड यू विल मेंटेन कॉन्स्टंट स्पीड. So that mechanism is called as speed governing mechanism. By controlling the discharge, we can control the speed. Tell me very honestly, is it clear to you? No one will ask you a question based on this, but you must know the things, you must know technical details of any device whichever you are studying. So what is the name of this mechanism? Yes. Am I audible? Yes, am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
What is the name of this mechanism? Why it is used? It is speed governing mechanism. आपण टर्बाइनचा स्पीड गव्हर्न करतो. स्पीड वाढला तर तो स्पीड कमी करू शकतो, स्पीड कमी झाला तर तो वाढवू शकतो. मला सांगा, स्पीड कमी झाला तर कसा वाढवणार आहे? येस.
ते माग ओढायचं, मागे गेलं की प्रेशर जास्त जाणार.
एक्सलंट, एक्सलंट. इथून डिस्चार्ज वाढवायचा. हा जर स्पीयर मागे गेला की डिस्चार्ज वाढणार, डिस्चार्ज वाढला की इम्पल्स वाढणार, इम्पल्स वाढला की स्पीड वाढणार. I believe that you are getting these
On
concepts.
bottom portion of buckets. This makes sure that water jet will not get interfered by other incoming buckets. One of the most important parameter of Pelton turbine design is number of buckets on the disc. If number of buckets is inadequate, this will result in loss in water jet. With lowering number of buckets, at some point of operation, complete water jet might be lost. This will decrease efficiency of Pelton turbine drastically. So there should be an appropriate number of buckets, which will make sure that no water is lost. Most vital component of Pelton.
So as an engineer, we have to design the buckets, we have to design the shape of buckets, we have to design the position of buckets, and we have to design number of buckets, so that maximum kinetic energy of water will get absorbed.
Is its bucket. Buckets are casted as single solid piece in order to avoid fatigue failure.
Okay. So tell me honestly, is the concept of turbine clear to you?
Yes, sir.
Okay.
Yes,
So, so in today's lecture, we have seen two concepts. Which are those? One is reciprocating compressor and one is turbine. Tell me, what is the function of a reciprocating compressor? Yes. Why we use compressor?
To increase the pressure of gases.
Yes, to increase pressure intensity of gases, we use compressor. Okay, very good. Tell me, why we use turbine?
produce mechanical energy into electrical energy.
Yes, to produce mechanical energy, if I talk only about turbine, it will produce mechanical energy from energy possessed by fluid. It converts energy possessed by fluid into mechanical energy. Right? Tell me, what are the components in a compressor?
Piston, connecting rod,
Piston, connecting rod,
Yes,
crankshaft,
Drum
and cylinder.
cylinder.
excellent. Okay, there are three
Inlet
things.
outlet valves.
Yes, inlet outlet walls are there. There are three things: suction, compression, and discharge or delivery. Can anyone tell me what happens in suction?
Air is up.
Very good. Air is sucked. How the piston moves?
Piston goes 0 degree to
TDC
180
to
degree.
TDC.
Yes, crank goes from 0 to 180, piston goes from TDC to BDC. Right? Inlet wall is opened and air is admitted inside the cylinder. What happens in compression?
Piston move from
Piston goes
BDC to TDC.
Yes, piston moves from
And
BDC to TDC. What is the position of both walls, inlet wall and outlet wall? Are they open or closed?
Closed. Closed.
inlet
Yes,
wall all
both walls are
Closed.
closed. So what happens? The volume of air
volume of
reduces
air reduces
and
and
pressure
pressure increases.
increases. Good. What happens in discharge stroke or delivery stroke? The piston is at TDC, the outlet wall is opened, and the compressed air is taken out from the cylinder. Right? Okay, good. Tell me last answer. What are the uses of compressed air? Yes.
for cleaning machinery.
Yes, please repeat.
For cleaning machinery in industries.
Excellent. For cleaning machinery in industry. Very good. Anything else?
For painting,
Excellent. For spray printing. Very good. Then for inflating tires of automobiles. Then in pneumatic circuits. Right? So there are plenty of applications of compressed air. Okay. Where you use hydraulic turbine?
in hydroelectric power plant.
Excellent. In hydroelectric power plant, we use hydraulic turbine.